Good day. This message is for all the marine engineers, most especially to those who are working on board, regardless of your position. As long as you are in the engine room, this message is for you, and it will also benefit the HVAC technician out there. A colleague of mine who is in Ghana, currently in class 2, sent in a question, and we discussed together and digest. It wouldn't have taken me anything to just pencil down my response for the benefit of everybody. But I think it's very important. It's not all about the exam, because after the exams, you are going out to the field to face the reality. So what I'm going to explain now is based on experience. It's based on practical, not just only what is in the book. The reason why I want to explain it, so that anybody that is watching this video will be able to understand the write-up. Yes. So please, the only thing I want from my followers, viewers, is for you to click on the share button, to share this message to benefit everybody. Share this message to benefit everybody. And if you are a marine engineer or you're working on board, please come closer and ensure you watch this video till the end. Don't just go up to read the write-up and leave it there. Watch it till the end and it will benefit. I will try as much as possible to give you a response to the question in the angle of practical, in the view of practical, so that you'll be able to understand the write-up. The question is from Ghana Maritime Authorities, Second Engineer Unlimited, General Engineering Knowledge, GEK, and also a UK question, United Kingdom Maritime Grammar question. I will read out the question for us to also hear it. It says, from an interpretation of the instrumentation, explain why a high pressure cutout in a vapor compression refrigeration system may operate under the following condition. A. Overcharge. B. Air in the system. C. Lack of coolant. D. Incorrect refrigerant. But first of all, what is high pressure cutout switch in the system? How do you understand the word high pressure cutout? I want to explain it in a way, a practical way, that everyone will be able to understand. Aside from what I have penciled down, I'll also explain it practically, in the angle of practical. A high pressure cutoff switch is a safety device to the system. Yes, it's a safety device to the compressor. His job is to stop the compressor from operating if the pressure in the system is higher than the rated pressure. It will tell the compressor to stop working, that there is an issue in the system. The reason why I say it is a safety device to the compressor. Should there be any high pressure in the system, it will tell the compressor to cut off. That is its own duty, to protect the compressor. It's a bodyguard to your compressor. Don't forget, the compressor compresses the refrigerant from high pressure to high temperature, right? And even with that, it needs something to cool it down so that it will be able to change the state from what? Gaseous to liquid. So the question is a practical question. You must have the practical knowledge to be able to answer the question. It's not just about reading on the book and write the exam and come out. After the exam, what happened? You go out to the field to face the reality. So that's why I'm taking time to explain this apart from what I've penciled down in the page. High pressure cutoff switch is a safety device to the compressor. Just that, a safety device, meaning that if the pressure in the system is higher than the rated, it will now cut off. It now tells the compressor to stop compressing the refrigerant. And there are many things that can cause high pressure in the system. Number one, too much refrigerant in the system. Number two, if there is a restriction in the system, it will cause high pressure. So if there's a restriction in the system and compressor is compressing, what do you think will happen? The unit will give way. There can be an explosion. So the high pressure switch is there to stop that from happening. So number one question, they say overcharging. Yes, if you overcharge the system, what happens? The high pressure switch will not allow the compressor to cooperate. Most time you will see it doing short cycling. It will start and stop because there's too much pressure in the system, you know. And how do you know if you have too much pressure in the system aside from the high pressure stopping the compressor from running? It's from your manifold gauge. So you really need to understand your system and know what pressure is rated for it to operate. So if the high pressure switch stop the compressor from working, you need to use your manifold gauge to confirm if actually what the pressure switch is telling the compressor to do is accurate, right? So if you have too much refrigerant or if you overcharge the system, the high pressure switch is there to tell the compressor not to work, that the pressure that the HVAC technician or you as the engineer is putting into the system is too much. That's just the answer. That's the answer on that. Then number two, A in the system. I always say that anytime you open the system to carry out repairs or maintenance, before you recharge the system back, you need to vacuum it. Why do you have to do that? Because air and refrigerant does not mix. It will not allow the system to operate how it's supposed to. It will also cause acidic corrosion. For example, for the engineers, if you have air in your fuel line, will your engine operate normal? It will not. It will cause issue to it. So if you have air in your circuit, air conditioning circuit, it will cause interruption. It will cause misoperation. It will not allow that system to operate the way it's supposed to operate. So what happened? The high pressure switch will tell you need to cut down. That is something wrong with the issue. So you need to correct that. Then number three, lack of coolant. Yes, lack of coolant. The HVAC unit can be air cooled and our condenser can be air cooled and also can be water cooled depending on the units, depending on the system, depending on the manufacturer design, depending on where it's going to be installed. It could be air cooled, it could be water cooled. So what happened? If it is air cooled, if your condenser fan should fail, what happened? The compressed refrigerant will not be cooled down. It will not also change the state at the condensing unit from gaseous to liquid. In that regard, what happened? It will cause high pressure in the system. So the high pressure will tell the unit to cut off, that there's something wrong. The same thing applicable to water cool. If your heat exchanger get choked up or get blocked, it will cause it will not allow the seawater to circulate the way it's supposed to circulate to cool the refrigerant to help it further change the state from gaseous to liquid. So the high pressure will detect that there's something wrong with the system and will tell the compressor not to start. Okay, what if the pump you are using to do that cooling fail? What happened? It will cause high pressure because it will not help to cool down the refrigerant and further change the state from gaseous to liquid. As simple as that. So you need the practical knowledge to be able to answer this question because it's a practical question. So it's not just all about going to the book and read and pass the exam and you let go. No, you need to know it practically because even if you pass the exam and go into the field, you will still face the issue. You will still face the HVAC system. So you should be able to know how to handle it. So if your pump should fail, if it is water cooled, it will cause high pressure in the system. And if the high pressure switch does not tell the compressor to cut off, it will return heat to the compressor and the compressor will overheat and cause damage. So the high pressure switch is the safety device to the compressor. It's the body guide to the compressor. It's there to guide the compressor so that something will not happen to the compressor. Then the last one is incorrect refrigerant. Yes, incorrect refrigerant. For example, if a unit was designed to operate with R1410A and you go ahead to recharge it with the wrong refrigerant, maybe R22, which is R22 is heavier than R114A. R114A manufacturer might say, okay, you need 410 psi in this system, right? And now you are using R22 to go to recharge in a unit that was designed to operate with R114A, and you want to follow that pressure that is there. It will cause explosion. It will cause high pressure. So if your safety device is not there, right, to tell the compressor to stop working, that there's something wrong with the system, there will be an explosion, which will eventually lead to fire. So I want to believe that this small explanation have really give you insight of what the answer I've penciled down there really entails. If you have anything to share, I am not the hero. That's the way I understand it. If you have more better knowledge about it, you can drop it at the comment section. Let's interact, right? Let's interact. Please share it to get to the marine engineers. Share it to get to the people that are working on board, especially in the engine room, regarding of their position. No knowledge is lost. Share it to them. Share it to them. And for the people that are in school, yes, I think if you should give this question answer to the examiner, you should be able to have your 95%, if not 100%. Thank you and see you some other time.